Here's a definition of dot product. So the dot product is denoted by the dot. So vector u dot vector v. Given two vectors u and v, the dot product of u and v is computed as u1 times v1 plus u2 times v2 plus u3 times v3. So we multiply the first component together and plus with the products of the second components of each. So u2 times v2 plus u3 times v3. Here's an example. Compute the dot products of the vectors for 1 minus 5 and 1 to 5. The dot product is 1, 4, minus 5. 1, 2, 5 is 4 times 1, 1 times 2, minus 5 times 5. So we have 4, 2, minus 25. So 6 minus 25 minus 19. Given two vectors u and v are non-zero, their dot product can be computed by this formula: the length of u times the length of v times the cosine of the angle between them. The angle theta between them is the angle between 0 and pi. So if u and v, either one of them, say u equal to 0 or v equal to 0, then the dot product is 0 by convention, and the angle between them is undefined. So the dot product u dot v is length u times length v times cosine of the angle. Here we can prove this formula using the law of cosine. So here's the triangle we have. If we have vector u and vector v, we know that u minus v is the green vector. So we go along minus v, and then we go along u. We get vector u minus v. Using the law of cosine, we have the law of cosine for this triangle. So for this one, we have c squared. So c is the length of this vector u minus v. So we use c for the length of this vector u minus v. We use a for, say, the length of u or v. We use b for the length of the other one. So we have a length of u minus v square equal to the length of u square plus the length of v square minus 2 times the length of u, the length of v, and the cosine of the angle between them, cosine theta. So we will compute this, and the rest here, the length of u, the length of v, the cosine of the angle, actually the right hand side of this equation, the equation we want to prove. So if we say that vector u in R3, so vector u has 3 components, let me call it x, y, z, and we say vector v is vectors a, b, c, then vector u minus v is vectors x minus a, y minus b, z minus c. The length of u minus v is the length of this vector, and by definition it is the square root of the first component square, so x minus a square, y minus b square, z minus c square. We can compute it, so this one equal to square root x square plus a square minus 2x times a. Right. X square minus a square minus x plus y square b square minus 2yb plus z square c square 2zc. Okay, we can write it as x square a square y square b square z square c square. So I bring all the square terms, the first term here, the second one, the next one, z square c square, and then the negatives in terms we have minus 2 times xa minus 2 times yb minus 2 times zc. We have it here, and we can do, say, one step further. Let me do the distribution, so we can group 2 outside, so we pull out 2. Inside we have plus plus. Okay, so for now let's leave it like that. So here is actually the value of the left hand side, and you can compute the value of the right hand side now. So here's what we do for the left, and now you do the same thing for the right hand side of this equation. U square, so length of u square, length of v square. So for our vectors u and v is given as this, we have length of vector u is square root x square y square z square. The length of vector v a square b square c square. Now let me plug in so everything inside this equation. The left hand side is the square of the length of vector u minus vector v. The length of vector u minus vector v is this square root. So if we square it, it will give us what happened inside the square root here. Here is the left hand side. The right hand side is length of vector u square, which is x square y square z square, right? Length of u is this square root, so length of u square would be what happened inside the square root. This is length of u square. Similarly, length of v square is this term square. So we have a square, b square, c square. We have the plus sign here. So we computed this term, length of u square. We computed the term length of v square. Now we have minus this term, we keep it the same. So recall that we know that length of u, length of v times cosine of theta is actually the right hand side of the equation we are trying to show. Now look at this equation. X squared cancel out, a squared cancel out, y squared, b squared, z squared, c squared. So everything here is cancel out. So what happened is minus 2 times this equal to minus 2 times this. Now we can do a bit further. We can even cancel out the minus 2. Right? We have divided both sides by minus 2. So we divided both sides by minus 2. Here's what we have. Note that x times a, y times b, z times c is actually the dot product of two vectors u and v. So here's our vector u and v, and this means that u dot v gives us x times a, y times b, z times c. So on the left we have u dot v, on the right we have length of u times length of v times cosine of theta. So actually this is what we need to show right here using the law of cosine.